Tonight, our topic is forecasting. Okay. So here's what I am going to cover. Let's move. We'll talk about, well, first of all, reason why we do forecasts. I think it's pretty much obvious or self-explanatory why we develop forecasts, right? Basically, it's for decision making. Last session, we talked extensively about the need for information, especially reliable information, whenever we need to make a decision. So forecast is basically, the first topic that I discussed in operations management, because really it is the basis of any kind of decision making, whether you're talking about decision making related to your business or to your work, or even for personal decision making, you will rely on forecast. Now, just one thing that I also would like to emphasize is that the various topics that we cover in operations management, we talk about forecasting, project management, inventory management, quality control, waiting lines. In the field of management science or operations research, and that's pretty much my background, my PhD work, my field is in management science, which is how I would describe it to people, is that management science is the sort of the quantitative side of management. We deal with numbers, models to make decisions, compared to or in contrast to other management fields or topics like organizational behavior, human resource management. These are what we call as sort of the softer side of management. Things that the softer side of management are those that deal with people, right? So management science, while it also deals with people, management science really deals more with processes. Okay, although we cannot take the human side equation from management science, but in my field, it's mainly talking about improving processes. Okay, so individually, these topics that we cover in this class is actually in my field. When I was going through grad school, my PhD work, I took semesters worth of classes in each of these topics. So forecasting, we spent like 15, well, we were on quarter system in my school. So we spent 10 weeks talking about forecasting techniques, various kinds of forecasting techniques. We had another course in inventory management, another quarter. So, you can think of our class as pretty much, sorry about that. You can think of this class as pretty much a survey of these various topics in operations management or in management science. So in other words, we're just seeing the tip of the iceberg. There's so much more under each of these topics that we really will not have time to cover. So the focus of this class is to kind of just give you sort of the important concepts and principles for each of these various topics. So we'll talk about qualitative forecasting methods very briefly, in contrast to the focus of tonight's session will be mainly on quantitative tools, such as, mostly time series analysis. Although we'll look at one of the things that you may have already seen in your undergrad or some other classes. I believe Mark Siders kind of covers this a little bit. He talks about linear regression in your 512. Did he? Okay, so that is another quantitative tool for forecasting. But our focus will be on time series forecasting. Okay, I'll define that shortly. Then we'll talk about simple and weighted moving average forecasts as a forecasting tool, exponential smoothing. And by the way, these two techniques, a simple and weighted moving average forecast and exponential smoothing, are what we call as in time series analysis, smoothing forecasts. That we'll talk about the various components of forecasts, and I'll talk more about what I mean by what is the objective or goal when we smooth our data. And then finally, we look at commonly used measures of forecast accuracy. All right, the mean or average absolute deviation, mean squared error, the mean absolute percentage error, and then briefly talk about tracking signals. Okay, so that's our focus for tonight. And then we'll follow this, we'll talk about concepts, right, principles, and then we'll follow that with application. So there are about 5 or 6 problems that are in this PowerPoint and also in an Excel worksheet. So we'll look at those examples using the template, the interactive operations management template, as well as I'll show you some sort of the basic Excel functions that I used in creating the forecasting models. Okay, let's see if there's a couple of. Oh, you went to the other. Mary Katie, could you please just send the link to Abraham? I think I sent it to him too, but
I think he's with us now.
He is with us now?
Yeah, Abraham's here. Yeah.
Oh, okay. Oh, thank you. I see you. Thank you. All right. Okay, so that's the our objective for tonight is to cover these items. All right. So as I mentioned, forecasting is really one of the most important topics, perhaps, in operations management, because this is the basis for any kind of decision making, impacts all aspects of an organization. You know, whether you're a financial planner, when we talk about scheduling resources, scheduling your human resource, process selection, you know, how you say render your service or how you manufacture products. Those are examples of process selection. And then location and capacity planning, inventory management, material resource planning. So it is important that we are able to develop an accurate forecast from which or with which decisions are made, whether you're talking about strategic decisions, right? Decisions that have long-term impact on your organization, or whether you're talking about short-term decisions, you know, day-to-day operations. Okay. Okay, so when we talk about forecasts, you know, whether the forecast is subjective, you know, wild guess, and we talked about the continuum of decision-making environment, you know, from when there's no information at all to perfect information. That whenever we select a forecasting approach or tool, we have to understand the features that are common to any kind of forecasting approach. And this is especially true when you're dealing with quantitative data, whether you're talking about correlation analysis or time series analysis. That the first assumption, or at least thing that we need to recognize and understand about time series analysis is this big assumption that the conditions in the past will continue into the future. Okay? Later on, when we look at time series data, when we evaluate the time series data, we're actually looking at how a particular behavior behaved in the past. Okay? So you can, this is something I think I mentioned this last time, is that if you are exposed to, say, somebody or a person that maybe because of your familiarity with this person, that if you provide this person with a certain stimuli or certain stimulus, that you can pretty much know or at least predict this person will how this person will react, right? So in the same manner, when we're looking at time series data, we're actually looking at how the variable behaved in the past, and then we use that behavior and project that into the future. Okay? Second, because we're not going to be dealing with, in most decision-making situations, you're not going to have perfect information. All right? In that sense, forecasts are rarely perfect, unless you have the crystal ball, which probably no one has. So when we talk about forecast, recognizing that there is probably no such thing as a perfect forecast, just you're looking at, into the future, that whenever we develop a forecast, we simply want to minimize the error. If this is your target, you have a certain target. If I can use this board here, if this is your target, your forecast could be, anywhere around that target. So when we talk about measures of forecast accuracy, what we want is to find a forecast that minimizes the forecast error. Okay. Third, forecasts for groups tend to be more accurate than forecasts for individuals. Last week we talked about this concept of law of large numbers. Okay, so if you are, let's say, if somebody were to ask me in this class, somebody stands up and says, "What is my?" I probably can say, well, knowing sort of the distribution of GPAs in a graduate school, that it's somewhere between, say, 3.0 and 4.0. Okay, that's a wide range, right? For forecasts or for estimating purposes, that's a range of 1. So whenever we forecast, we want to make sure that the range that you come up with is narrow enough, meaning the margin of error is small, right? And that you can also, and this is a statistical concept, that you can also assign a high degree of confidence within that interval. So you can say, hey, it's probably, the average is probably 3.3, give or take 0.1. So the margin of error is 0.1, the range must be 3.2 and 3.4. And that's a better forecast or estimate than saying, it's between 3 and 4. In addition, when you say the average GPA of this person is between 3.3 and 3.4, or say 3.2 and 3.4, you say, I am 90% confident or 99% confident that that range contains the true GPA of that student. Now, if you were to ask me, what is the average GPA of the students in this class? And that is a much easier number to estimate. Now, I can say maybe with high degree of confidence that, I know that the average GPA of, say, MBA students is like 3.4. I can say with high degree of confidence that it's 3.4, give or take, maybe 0.5 or 0.05. 0.05. Which is a better estimate than saying give or take 0.1. Okay? So from a forecasting perspective, it is much more difficult to forecast, say, sales or volume of activity that will happen, say, next month in May, because you're talking about a particular period, then you would say, for the next 5 Mays, what is the average, volume? So it would be easier to do the forecast for group because you can talk about averages. Fourth, again, because we're forecasting into the future, that forecast accuracy will decline as time horizon increases. In other words, it's much easier to forecast. An example would be the Dow Jones Industrial Average, for example. If you ask me what the closing price will average tomorrow will be, I can just say, what was the closing price today? Versus ask me, what is the average going to be a year from today? It would be harder to predict what that number will be. Okay? All right, so what is it that we are looking for in a good forecast? Obviously, number one is accuracy. Okay? We want to have the difference between what actually transpires and what you say it will be, so that we want to minimize the error. In forecasting, the error is also referred to as a residual, okay, or deviation. So these are terms that are interchangeably used for error. Variance is another one. Simple definition of forecast error. So that's accuracy. Second, your forecast is consistent. Okay. Now, are these two the same or are they different? If they're the same, then don't have to worry, right? But in terms of, it's listed there, that means that they must be different. Okay, the question is, what is the difference between a forecast accuracy versus consistency? If anybody listened to the podcast I posted, because it explains clearly in that podcast the difference between a forecast accuracy and consistency. And it uses the golf as an example.
One of the biggest takeaways from that podcast is the forecasting may be inaccurate, but it's consistent, and therefore it's almost like you can realign your forecasting off of that model because it is consistent. So if it comes up short, 20% each week, then you can just account for that.
Okay.
But if it's giving you variable data all the time and it's
Which is you're talking
inconsistent,
about, consistent.
then how could you? It's not very valuable.
Okay. Yes.
Say with consistency, you're using the same processes that you used the previous year.
And for consistency?
Yeah, for consistency. The same process, the same, whatever your process was for forecasting last year, you're going to use that same process to be more consistent.
Well, the accuracy and consistency actually pertains more to the result rather than what you use for forecasting. So I think this is kind of something that, screen share stop. So let me reshare. We had that one. Example I like to use when discussing this difference between forecast accuracy. Okay, so we have tool 1, tool 2, whatever that these two forecasting tools might be. And here's the target for each one. Okay. So, all right. So say that tool 1, let the yellow dots represent your, forecasts. Right? So it's all over the place. Above, below, on the left, on the right. So how would you characterize tool 1 using the words accurate versus consistent?
consistent but not accurate.
Consistent but inaccurate?
Well,
Or let me put another example. Here's the other one.
so that's
It's
consistent.
really
but not
obvious.
Yeah.
So you will define or at least describe one as what?
This is
Not as accurate?
Yeah, one is repeatable.
Repeatable, what is which one? Oh, one is repeatable?
Consistency is more repeatable. It doesn't necessarily measure as to being right. It's just you can repeat the results.
So number two should be scattered,
Should be what?
should be more scattered.
Well, this one is more scattered, so we will consider this as, because the distances of the yellow from the, if you let's say compute the error in terms of average, maybe the average error here will be lower, so we will say that this is relatively speaking, relatively
Accurate.
accurate compared to two, but is not consistent. Right? Whereas number two, if you look at the errors, the distance from the target, it's much farther. So the average, if you compute the average deviation of this tool, it'll have a higher deviation than one. So this is less accurate, but more consistent. So, in forecasting, we try to understand, like I said, behavior. So here we see how this particular tool behaves, and then same thing here. And we use that behavior to adjust our forecasts. So if you were using a forecasting tool that is represented by number two, that is a better forecasting tool than this one, because you can use, this, what you observe as an average, sort of a consistently underestimating or consistently overestimating. So that the next time you use number two to forecast, you can use whatever average error you have and then adjust the forecast accordingly. Okay, so in that podcast example, have a golfer, this is probably what I am too, consistently slicing, 100 yards off target. Or if you were, say, go to the shooting range, here's your target, and then on this particular day, all your hits are to the left. Then maybe there's a wind it's going this way, that's pushing the bullets to the left. So you can make your you can adjust accordingly. Yes, Brian?
Well, yes, I would have to account for the caliber of the round and the level of fall.
Right, yeah. So the point here is that, you use your observation to make the adjustment. Whether you're talking about golf, you're talking about the shooting range, or you're talking about business forecasting. Okay?
Very good.
Understand behaviors. Use that to develop your forecast. Very good so far? Move forward. Oh, erase those. All right, so we talked about the difference between accuracy and consistency. One of the measures of forecast accuracy, I talked about the tracking signal. A tracking signal is, if you're using software to compute the tracking signal, I'll show you later on the number that you would want to observe in terms of tracking signal. Tracking signal is used to measure forecast consistency as compared to the three other measures, which are the MAD, MSE, and MDE. Okay, third element of a good forecast, expressed in meaningful units. And when we talk about meaningful units, we're not necessarily talking about dollar values. Okay, we're talking about, like, for example, in the BSG game, your meaningful unit there will be what?
Shoes.
Well, what about chew? what basic unit of shoes? Pairs of shoes, alright? Because if you're forecasting in dollar terms, that tends to hide the true volume of the units that you're going to produce. You know, if you're developing a business plan, for example, and the business plan, bed and breakfast, what would be the meaningful unit of a, say, 5-bedroom bed and breakfast?
Your occupancy rate,
I'm sorry,
occupancy rate,
not occupancy rate,
nights,
the units that will be the basis for your revenue.
number of rooms.
Not only number of rooms,
Number of bookings.
not beds.
Available nights to be.
Well, so my example was, this is a 5-bedroom house.
Oh, the whole house.
Well, the 5-bedroom, what's the, you know,
Occupants.
not occupants, you don't charge by occupant.
Can you repeat the question?
What,
By night?
what is, I'm sorry,
Can you repeat the question?
five rooms, this bed and breakfast. What would be your, you know, if you were estimating your revenue for the year? You will figure in the occupancy rate, but
Per night?
where will you apply that occupancy rate against?
Your
The number of
reservations?
days in the year,
I'm sorry,
the number of days in the year.
plus times,
Their market values.
Average nightly rate.
not quite, well, that will give you the revenue. What I am asking is, what would be the meaningful unit?
Total available like room or I guess like spots per year booked. So you could take like 365 times 5 and then
There you go.
number of that you
We
have.
call it room nights, right?
That's
I'm sorry, I did not hear you, Rose. But it's room nights, but the point I'm making here is that you know, you want to make your capacity as concrete as possible. And this one, if you define the basis for revenue, which is a room night, then you can estimate your maximum revenue given your average price, or your expected revenue based on occupancy rate. Okay? Do you get what I'm trying to drive out here? So if you're running a consultancy business, let's say this is a 1-person consulting business, what would be your
Billable hours,
billable hours one?
Turnover rate,
Turnover rate of what?
depending on if you're a service as to whether.
Well, turnover rate applied to what?
Turnover rate applied to billable hours, so the combination of the two.
Well, then they'll just use billable hours.
Well, meaning like a combination of the two, so.
If you're talking about maybe a restaurant, that probably would be more applicable. So because the restaurant might have, say, 20 seats.
Yeah.
Right? The restaurant is open only, say, 10 hours.
That's a 4 up or 12.
Then you can apply that turnover rate that, you know, for every, you know, how long on average do customers stay in the restaurant? So that you can apply that.
That's number of plates per table. I'm thinking from a design perspective.
Huh?
So when consulting for a design, it's, for me, it's numbers of hours of consultation, but if that's paired with an actual project, adhering to the turnover rate.
Oh, okay, well, you can also, instead of turnover rate, you can probably estimate the number of hours. If you're not billing by billable hours, you're billing by, say, project.
Yeah.
Then you can talk about, you know, convert the average hours you spend per project.
Yeah, it's a.
Rates per service or rates per project.
Rates per,
Like I
can you,
I have different hourly rates as a consultant based on what I'm doing. I charge more when I'm actively writing a grant than I'm researching grants. That's a lower.
oh, well, yeah, so the basis will be the billable hours, you know, so the rate just depends on what it is you're trying to do. Fourth, easy to understand and use. Of course, that the reason why we do that is, you know, I think you guys have heard the KISS principle, right? Keep it simple.
Yeah. Or occupancy
I
rate.
have a question about this.
Sure.
Okay, because I know some of us are in Capstone and we're probably overthinking the math that we have to do on these cases, right?
Uh-huh.
So my thought with that is, if I can prove my point as simply as possible, really obviously, with as little math as I need, is that bad?
No, I mean, if you can prove your
If
point
it's
in the
thorough.
simplest way.
Yeah.
You know, it also depends on your audience.
That's fair, that's fair.
If your audience is composed of, you know, executives, then you probably don't have to keep it simple,
Got it.
right?
For the executives, you want pictures, pictures.
Yeah, you want to impress them with your numbers, right?
A good story and a picture.
Okay. Must be communicated in writing. This is important. Again, this is from when we develop forecast, we actually follow up and see how the forecast performed. Because forecasting, choosing a forecasting tool is not a linear, you know, you do it once and that's it. It's actually an iterative process. You develop a model, you implement it, you track the numbers, and then based on your measures of accuracy and consistency, you know, you tweak it, you adjust the forecasting tool. Okay. Yeah, you communicate it in writing so that everybody using the forecast has a good understanding of maybe your assumptions, you know, why maybe perhaps they can suggest some improvement, you know, if the forecast is not generating the kind of results that you're expecting. And then finally, cost effective. All right. And we talked about last time about you weigh the cost versus the benefit of information. Okay. Steps in forecasting process. First one is determine the purpose of the forecast. I think I'm missing a slide here. One of the slides, important slides, talks about why we forecast. Okay. Well, one of the reasons why we forecast, actually the main reason is so that we can plan for the future, anticipate problems that may occur. Yes.
How's forecasting gonna work? I know with just how rapidly things change now with innovation and the use of AI and how that's completely changing the market.
Yeah, it depends on if you're talking about changes in technology. One of the techniques that is used there, I think I have that here, is the Delphi method. It is using experts in the field. It's kind of like a survey of experts in the field, and you come up with a consensus among these experts. But you know, for most of us, at least for the work that we do, you know, we're talking about, like, for example, in my line of job, you know, I'm responsible for developing a schedule, you know, how many classes to schedule for next year. You know, we schedule, at least in the School of Business, we schedule about 150 undergrad and graduate courses. So I use forecasting, you know, but the kind of forecasting I do is it's, you know, for the short term. I don't do long-term forecast. A long-term forecast in my line of work would be more for developing budgets, for example. And I'm not involved in sort of the bigger university forecasting. I'm forecasting more in terms of our program. And that is much easier to do because I'm talking about a year from now. And one of the tools that we'll talk about, the simplest one to implement, is known as the naive approach, which simply means that if you're forecasting tomorrow's value, like the Dow Jones average I cited earlier, look at closing today. Chances are it'll be very close. You know, maybe change 1%, but that's a small margin of error. But if I'm looking at the demand for, say, the MBA or the business program 5 years from now, there are so many things I have to consider. And I probably will not be as accurate forecasting how many courses I will be scheduling 5 years from now compared to number of courses I will be scheduling next year. Okay? So I don't know if that addressed your
Yeah,
question. It depends on the
It's
situation.
a qualitative method then.
There are quality, yeah,
It
so
would
if
be
you-
unstructured.
I'm sorry?
So it would be unstructured data that you're.
not necessarily unstructured data, but if you don't have access to current information, the qualitative approaches will be useful. You know, for example, I don't know if you guys probably were not born when Coca-Cola decided to introduce the new formula. This was way back in or even the most recent case,
In the 80s.
Cracker Barrel.
Yeah, it was the eighties.
You guys are
I'm
following
alive.
that?
We got some old ones in here.
What? You guys are young, you know. But you know, you remember what happened to Cracker Barrel? They changed their logo. And what was their, this is, I think, maybe a case that John will probably have in your class. I don't know, but this is a good case. The classic Coke was a very good example. What was their mistake? That actually turned into a positive.
They were trying to
You guys
compete with
remember?
they were trying to compete with Pepsi, so they came out with a new formula and their customer base completely hated it. And that's
Right. So what was the mistake that Coca-Cola made when they introduced a new formula?
Calling it new code.
No market research.
No. Very limited market research. They, I think, based it on one community. I can remember exactly where, but when they did the consumer survey, it was not done properly. It was not representative of the regular Coke consumers. I was one of them, by the way. I hated the new formula. Was tasted like Pepsi, actually. Same thing happened with Cracker Barrel. They did not do their consumer survey properly. So, you know, new ideas, new services, new products. The quantitative approaches may not be sufficient. You have to go back to, you know, your salespeople, because they are close to the consumers and they probably have a good idea of what and how consumers will react or have an opinion if you were to change formulas or if you were to change the logo. So that is a good source of information. Okay, so let me go back here. So determine the purpose of the forecast. In the podcast, it talked about two things. Why we forecast? What were those two things? It's for planning.
Deciding what we do with our resources.
I'm sorry,
Deciding what to do with resources.
what to do, not
Where to allocate.
two things.
Supply and demand, so how much is gonna
Not
be.
planning the demand. It has something to do with the system that you have.
Determining which system.
Planning the system. Planning the system. When you say you're forecasting to plan the system, this is more decisions that are more strategic. We're talking about capacities. Should you expand? Should you, this is related to your BSG game, should you have a plant in, you know, Asia Pacific or Europe or US, North America? So for planning the system, you're talking about more long-term, long-range forecast. But in my case, the planning I do is more short-term. It is planning the use of the system. So it involves, well, daily activities or things that involve staffing, human resource planning, materials planning. Okay, so that is planning the use of the system. So depending on whether you are developing a forecast to plan the system or plan the use of the system, that will be that purpose. What is the purpose? Once you have determined the purpose of the forecast, whether it's for strategic or for tactical or operational decision, then you establish a time horizon. So strategic planning typically requires 5-10 years of forecast, whereas planning the use of the system can be hourly, daily, weekly, monthly, and depending on what it is you're trying to forecast. If you're running a restaurant, what would be your time horizon for planning a time bucket? Hourly?
Week for wedding.
Hourly, not necessarily a week, but even shorter than a
Per
week.
shift or meal.
Daily, you're talking about, these restaurants exhibit seasonality throughout the week. So your planning for a restaurant would be a daily, so that you can schedule your staff accordingly. Some days you'll probably have, X number of servers, some days you can reduce that. Same thing is true when you are planning purchases of ingredients or material that's used in the operations of your restaurant. So that would be the time frame. And then select the forecasting technique. And then various forecasting techniques. We talked about that kind of, whether you use qualitative or quantitative or a combination. These are not mutually exclusive approaches, by the way. You can use a combination. Right?
So historical data to show peak periods, so that way, like during the week, you can figure out, I have more people coming in at this point.
Right. So that's again, you look at past data. Okay.
So is this like the Six Sigma DMAP process?
Basics.
It's like define, measure,
Measure,
control.
Well, you can apply that forecasting also, because like I said, forecasting is an iterative process. Right? Gather and analyze appropriate data, prepare the forecast, and monitor the forecast. So you can apply the same DMAIC concept to this. You define what it is you're measuring, right? You measure and then evaluate how it is performing, then you can control it. All right, so I think I already kind of defined the qualitative techniques, the Salesforce, a survey, consumer surveys is where you go directly to your target customers and obtain, ask questions related to what's important for them. We talk about taste, price, aesthetics, and all features that you think would be important. Just for
Would you say that also developing a persona would
For
be used?
what?
Persona,
persona.
Yeah.
For
what you would have for your perfect demographic.
well, yeah. Well, then now you can developing a persona can be informed by the information that you get from.
Yeah, because I've had to do that for marketing and e-commerce.
Sure. Yeah. So hopefully, when you develop a persona, it's something that information that you obtain from your customers, rather than you thinking what they will be, right?
Yeah.
Because we make that assumptions about consumers. Now, the quantitative techniques, the most commonly what you've seen in your statistics classes are this what we call as causal relationships. Where you have a variable of interest. For example, let me give you a simple example. In the BSG game, your variable of interest would be estimating the number of pairs of shoes of particular model sold. So that's your variable of interest. The predictor variable, so this is a causal relationship. We denote that response variable or a variable of interest as y. So that's true in the time series analysis too. But here you are using what we call as a predictor variable. So one of the predictor variables in the shoe industry, the shoe game, is how much you spend on advertising. So if you're only using one predictor variable, that is what we call as a simple linear regression. Simple, not necessarily because it's easy, but simple because it has only one predictor variable. But in that game, there are many predictor variables. You have the price. You have how much you spend on advertising, right? How many models you produce. The SQ rating that you're aiming for. And if you are using information related to these more than one predictor variable, then you're talking about a multiple linear regression model. Okay. So in causal relationships, there are more models than just these two. We can talk about nonlinear models, but those are again beyond the scope of this class. For us, keep it simple, we will use a time series forecast. And you can use this in many situations. This can be used because you have access to historical data. Like, again, using my role as developing number of sections to offer next year, can look at historical data, like use last year's information, this year's information to inform what we need to do next year. Okay, so I'm using historical. But if I'm going to look at, say, I'm just using the School of Business as an example, in terms of the number of students we serve, over a 10-year period. And this is not a secret. Our number of students has dropped since 2017. From like 800 students in the undergrad, now we're just down to 400. So think about in terms of for staffing purposes. We can have as many faculty members we had in 2017 as in 2017. So that is a kind of long-term forecasting that is important because it has an impact on the financial sustainability of a unit. And as I mentioned earlier, in terms of the time series forecasting, we look at behaviors. You observe what's happening here. So when we are looking at data, time series data, we actually look at two things. Behavior or variation that is explainable, like a trend. As mentioned, the enrollment trend in the school business, it's dropped over the last 10 years. And there's a fluctuation from year to year, some variation. We call that random variation. Okay. So between a trend and random variation, which do you think is easier to predict? The trend, right?
That has historical data.
The random because of the random behavior, it's not as easy to predict. Okay, and we express this behavior in equation form, such as in a simple linear. So if you graph, so one of the first things you need to do when you have a time series data, generate a time series plot, because a time series plot will show you the variable is behaving in a certain way, or if it's just purely random. And we use this, we convert the behavior in equation form and use that to extend, project, extrapolate into the future. And let's go back to the elements of a good forecast, or at least the features common to all forecasts. Even if you have a good trend equation, that trend equation perhaps pertains mainly to that relevant range of data. That when you try to project, inaccuracy will tend to increase over time. Why? Because conditions change more over a long period of time than within a short period of time. Okay, does that make sense? Okay. Now, talk about behavior of data. When we are analyzing time series data, we try to sort of decompose the data. And we talk about different components. In these four, the top three, the trend, cycle, and seasonal, are what we call as explainable. Okay? Whereas the bottom one, irregular or random, they're not easy to explain or to even forecast. But we can minimize your forecast error if we understand how a variable behaved by looking at patterns. Now, let's define each one of these. Trend is defined as a gradual upward or downward movement in the variable. This is typically used in marketing, when you're looking at product life cycles. You guys see that from Cider's class? What are the different stages of product life cycle? And why is it important that we understand product life cycle, or the cycle where a particular product or service is in relation to that cycle?
It's an initial growth.
Well, before you grow, there's something you have to do. R&D. Huh?
That's not on his life cycle.
Oh, really?
No.
You can ask him about, his hip replacement, things. So you have to do an R&D first, and then you have to introduce, and then you have the growth, maturity, decline, right? Why is it important that we need to know where you're at in that product life cycle?
Forecast revenue.
You have,
Forecast,
you have to do different things in each cycle.
Yes, you know.
Like different resources,
Yeah.
different.
right, but eventually it talks about profitability,
Right.
right? Where is profit really highest? At what stage? In the growth. And then if you are on the maturity side, if you're going to a market where this product or service is mature, you will not get as much profit. Okay? So that's why it is important we understand product life cycles, because it has an impact on profitability. Okay? Why does Apple produce iPhone every other year? Why do you think that is? Or why do companies have to continually improve their products?
Change in technology.
Okay, not only changing technology, but if you have a product whose life cycle is relatively short, such as your phones, or your product life cycle would be going like that. So maybe would span maybe a 2-year period.
Also planned.
Redundancy and what's that? Obsolescence.
This one becomes obsolete. So if you don't continuous research and development, your product you'll start to lose profit. But in order for you to sustain or even improve your profitability, you have to continually, do R&D, introduce new products, so that you can at least maintain your profitability. Okay? So the product life cycle is expressed by this.
It's also dependent upon the economic model.
Hold on, say that.
That depends upon your economic model. So are you
Okay, so that would be,
linear or circular?
that would be,
Because then your methodology is going to change.
so talking about economic or business cycles, that is the second component there. Whereas a trend is a gradual upward and downward movement. A cycle is within a trend. So this coincides with the economic cycles or business cycles. So if I were to represent this don't know if I have the yeah, look at the Dow Jones Industrial Average from 1900s all the way to, this is not updated because this only goes up to 20 or to 2005. So it's missing like 20 years worth of data. You can see, no,
Like if you deselect the image, maybe.
Yeah, because you have to click.
oh, is it the image? No, well, it's-
Yeah, then you can click into the.
Alright.
Section.
nope. Anyway, you'll see the peak and valleys in this 100-year starting of the Dow Jones Industrial Average. And you can see certain peaks. This was in the late 20s, and then you have the big drop. It coincides with the Great Depression. And then after the Great Depression, from the 30s all the way to like the 40s or 36, going all the way up here. Maybe World War I, 34, and then World War II. Right,
A little bit for that.
and then continues to grow until the like 60s. Let's see, baby boomer generation. Yes,
I think if you select annotate on the bottom right over there, you,
son,
yeah, that might disable that
probably.
feature.
Oh, no, sorry, I wouldn't do it. Touch that now. But anyway, the point I'm making here is that the cycle coincides with certain political, social events. You know, we had in the 2001, I think over here, it's a big drop there, and then it started to go back up again. What was the next bust, or at least,
08,
what?
08.
What was that? What happened there?
Housing market crash.
Was it the housing market? Okay, and then after that,
Recession.
back up? Well, no, the dot-com bust,
That was like 02 or something, wasn't it?
somewhere there, yeah.
That would have been probably that little diff right there.
And then, yeah, the most recent one is COVID. Now we're back up again. Well, that's fine. Now we have, yeah, something happening. But the point here I'm making is that also, is that when we talk about things that are difficult to predict, are events that impact businesses or the economy that are irregular. Again, COVID, wars, changes, sort of social norms. Those are things that are difficult to predict. Very good? Should we take a break?
Sure.
Yeah. Okay, yeah, so let's take a 5-minute break and I need to refill my vodka here.
Yeah. It's crazy today.
Some guidelines in terms of what forecasting method might apply. This is not necessarily a, you know, if this is great, if this is true, use this. No, again, you have to look at the purpose of the forecast so that you can determine which of the forecasting methods might apply. Oh, did I continue? Did I complete this? I think I stopped at defining a cycle. So the third component of a time series is what we call as a seasonal. So in terms of time, this is shorter than a cycle. So in fact, a season is something that is part of a year. It can be quarters or semi-annual, or it can be monthly. It can even be daily. So again, depending on what it is you're trying to observe, the time horizon and the time bucket will depend upon what you are trying to observe. And earlier, I talked about exponential smoothing or the moving average as what we call as a smoothing technique. Smoothing in the sense that when we apply, a trend or a moving average, what we're really doing is to remove the variation from irregular all the way up. Okay, so when you are developing For example, here, this is an example of the demand, or I don't know what product this is, but when you plot the demand, the actual demand, that is represented in the black jagged line. So obviously you see here a trend. Okay, it's an upward trend over 30-week period. But as you develop a moving average, 3 weeks to 9 weeks, so the more number of periods you include in a moving average, what that does is it smooths out your time series data. Okay, so the dashed blue line represents the 3-week moving average, and then the red represents the 9-week. When you develop a linear trend such as this, you know, this black line here, it smoothed out all the seasonal as well as the irregular variation. So you're just left with a trend line. Okay. So this is an example of number of meals served in a particular restaurant, and they observed a 28-day period or 4 weeks. And you can observe a strong seasonal pattern. The days of the week where you expect the highest number of meals served, evening meals served, and then days when. So for a typical restaurant, that this might be a pattern, but this is not applied true to all restaurants. If you're talking about breakfast buffet restaurant, I'm sorry,
Brunch.
brunch, or yeah, those that serve, you know, breakfast buffet.
Hometown buffet.
What?
Oh, I'm saying hometown buffet.
Hometown, yeah, like hometown buffet, you would expect a pattern to be different from this. Maybe the Sundays would have the highest number of meals served, right? Number of customers. Here in Ashland, you know, this may not be typical, especially when the Shakespeare Festival is on. And so now what I'm trying to say here is that the time series data that you have to collect should be particularly relevant to your type of business or wherever your business is located. Okay. Now, for forecasting purposes, we talk about this concept of understanding seasonal factor or seasonal index. Okay, especially if you develop a linear model or a time series like this, and if you want to project, for example, Monday of the 5th week, if you extend this black line and say, hey, you know, your forecast is over here, that kind of forecast is what we call as seasonally unadjusted forecast. Meaning when you say unadjusted, it does not contain the seasonal component. Okay? If you were planning for Monday, and you use this linear trend to plan for Monday, you have to adjust your forecast to include the seasonal component. Right? And we do that by the use of what we call as an index. We apply the index to the linear trend forecast to come up with your forecast for the period. So a seasonal factor is defined as the amount of correction needed in time series to adjust for the season of the year. You know, so for example, for instance, if you know that the Monday over here is typically, if you just kind of, eyeball the Mondays here, over here, so you're saying that the Monday sales is typically lower by how much? Well, we can compute that later on. By how much relative to the average for the week? So your index here will be less than 100. Any time you see above the line there, its index will be higher than 100. Okay? So there are two ways of adjusting forecasts. One is known as the multiplicative approach, where you have your trend and then you multiply the index. This is typically what is used, the multiplicative index, or you can use the additive. There's the additive seasonal, where you add a component. So an index is used, there are two uses of an index. One is to seasonalize a forecast. The other is to deseasonalize an actual value, meaning remove the seasonal component. And the way you do the seasonal forecast to deseasonalize is you can divide the actual by the index. Whereas to adjust forecast to include seasons, you multiply the index and the forecast. Here's another another way of looking at a seasonal index. So an index is an expression, the volume of activity that occurs in a particular period, particular season, with respect to the average of those seasons. Okay. This is information on this is an old data, but it's still probably reflective of the hospitality or businesses in Ashland that caters to tourists. Okay. This is a distribution of the amount of sales tax collected in Ashland. So it is reflective of the volume of activity that's happening in Ashland for businesses that are tourism based. Okay. So you can see here that if there were no seasonal differences in these businesses, then the percent distribution here should be around 25% for all, right? But you see that in some quarters, the amount of tax collected is higher, like the third quarter. It's 28%. So in terms of if you were to convert this into an index, you relate 28 to 25. And 25 is the without seasonal variation. So that's what you see in this slide. The 25%, the red line, represents the no seasonal variation or the average for the year. So the index for the second quarter is 32%. That's the share of the second quarter here relative to 25. So its index is 128 or 128%. So if you were to apply this to a restaurant example, if you project the sales number of meals served in Monday of the fifth week, and if you know Monday is typically 95% of the average, so whatever number of meals that you projected there using the trend, you multiply that by 0.95, that would be your seasonally adjusted. So this slide talks about how an index is used. I mentioned this earlier that an index can be used to seasonalize a forecast to add the seasonal component. Seasonal index can be used to deseasonalize an actual value. You might ask, why would we remove a seasonal component of an actual value? Simple answer is so that you can compare that performance from one period to the next. Because you're comparing apples to apples. Yes,
Is that kind of like when you right size financial statements?
Right, when you say right size, are you talking about?
Right sizing, it sort of makes it all even, so you can compare, like, if you have two different sizes of businesses in the same sector. And you wanna compare the businesses, you have to make everything the same size.
Well, yeah, I think it's in the same principle, is that you would want to adjust, account for size. Okay. Or, if you're looking at your performance, say in January, you want to compare your performance to March, let's say that you are, one of the examples here is a car dealership. Sales of cars are affected by seasons, right? So a January number
Well,
should not be comparing your January,
well, it affects different makes of cars too, like trucks, for example,
Like truck.
SUVs, like family cars would be more seasonal, like,
Right.
yeah. Minivans and things like that would be more seasonal during the spring and summer during vacation, things like that.
yeah, so if that is the case, then you should not be comparing your actual units sold in January versus March, because the difference you might be observing is not necessarily you perform better in one month or the other, but rather the difference might be due to the seasonal differences. Okay, so if you want to compare performance within a year, then you have to remove the seasonal component. It's similar to when you want to compare your salary this year versus next year. I think I touched on this concept last week. You want to measure your buying power by adjusting your salary to inflation or remove the inflation component. So you can compare the buying power of your dollar this year compared to next year. Okay?
Do you think this could be used to get a seasonal index of climate change? For example, like winter products. Like in Wairika, it continuously snows less every 1 week less every year so far. So last year there was a snow season of like 2 weeks. This year it was only like 1 week.
Well, that would be more, irregular variation. Because seasons tend to be over a long period of time, tend to follow the same pattern. But if you have an unseasonably warm or unseasonably cold, then that would be more of a irregular variation. All right, so measures of accuracy, don't have to memorize these formulas, but just understand what they represent. So the MAD, mean absolute deviation, it measures a forecast in terms of absolute terms. Meaning you're not concerned whether your forecast is below target or above target. You're more concerned about how far off on average you were from the target. Okay? The MSE, mean squared error, look at the main ingredient, if you will, of these forecasts. It's the difference between the actual and the forecast. Okay? The mean squared error is you have the residual or the error and it is squared. Okay? Now, question is, why would we want to square an error? No. If you, Scott,
For sensitivity purposes?
for sensitivity purposes, you would want, why would you want your forecast to be sensitive? For what reason? Good answer. There's the why. Okay, here's the answer. If the cost associated with a forecast error is non-constant, meaning the bigger your forecast error, your forecast error goes up exponentially, then you would want your forecast, you would want to be able to be sensitive to huge forecast errors so that you can avoid big forecast errors.
What would be an example of a forecast error?
But I'm sorry,
What would be an example of a forecast error?
if your forecast is especially for strategic planning, where you have big fixed costs overhead that you will spend, this fixed item, then your forecast, the cost associated with forecast error will tend to be much higher if your forecast is incorrect. But if your forecast error tends to have a constant cost per unit error, then you're not worried about the sensitivity of your
Because it's consistent.
the MAD should be sufficient. Yes.
How does squaring it? I don't understand how.
Okay.
Solves.
Oh, yeah, why does squaring it? Because if your forecast error is, let's take this one. Just try to move. If your forecast error is 1, so this is error, okay? E squared, this would be 1. If your forecast error is 2, that's 4. If forecast error is 3, that's 9. If your forecast error is 10, 100. You would want to be able to be flagged. Yes,
So does the mean squared error make your error more obvious?
correct. That's why sensitive, if you want
Got it.
your measure of forecast accuracy to be sensitive to huge errors like this, because that you want to avoid that,
Got it.
right? But if your cost per unit is constant, then the MAD should be sufficient. Okay? MAPE, when do we use that? Here, the MAPE is you're comparing the percentage errors. You use this, and I think the example that Rose gave earlier is if you are comparing two tools that are used to forecast two different things. Okay?
It standardizes.
Exactly, it standardizes, converts the error into percent. Okay, you know, this example I typically like to use is, let's say you're taking 2 classes, right? And both classes have quiz today. In one quiz you've missed points, in the other you missed 2 points. In which quiz did you perform better?
It depends how many points were available.
Exactly. So for you to be able to compare your performance, you have to relate the 5 to however many points that quiz had to. Does that make sense? Okay, so whereas these two, the MAD and MSE, you're comparing 2 tools that are used to measure or to forecast one variable. Okay? And the tracking signal. So it's used to measure consistency. Okay, so what's a good number of a tracking signal? Anybody?
Greater than or less than 3.75.
I'm sorry?
Greater than or less than 3.75.
Okay, well, it's a rule of 375. If you go beyond plus 375, that means that you are under forecasting consistent or over forecast?
Is it,
Under.
I'm sorry, I'm talking too much. Is it, if I'm looking at like a graph and I see the y-axis, we wanna be toward the middle?
Well, more and
That
more
kind
kind
of
of
the idea.
dispersed, so if you're looking at, if you computed the tracking signal of this red,
Yeah,
they'll be constantly under, so the tracking signal. So here's where, you know, using ChatGPT would be a good thing to use if you're trying to understand tracking signals, you know, what number is good or what numbers are good. Wish there was knew how to do a global erase.
Okay, that's ChatGPT.
Yeah, let's ask ChatGPT because I don't know either. So, well, so it gives you the formula computation there, and gives you interpretation, and then what to do when you have a tracking signal that is above. So it's adjust. Okay? It depends on whether it's above 4, +4, or below, or higher, below -4. It even says, connect this to my MBA 514 forecasting examples.
it's so creepy when it knows what you're doing and you ask it stuff.
Oh, because it's
like-
already sort of
it's
tracked.
working on a paper about such and such and such and such, and it's like.
I prefer that, yeah, I like
I don't
that.
like it.
That way I don't have to keep up.
Yeah, I think I've set this so that all that information I feed it is confined to the information, it's not shared outside.
Yeah.
So I think you can control that. But the more I use it, it remembers things that, kind of scary, isn't it?
You create a caricature of you, of what it knows about you.
Oh, interesting.
Yeah.
I don't wanna do that.
I want you to do.
I'll do it on, in my office, but when nobody's watching. Because you never know what it shows. Okay. Oh, I don't know if folks that are Zoom, are you seeing my? I don't know if they're seeing ChatGPT.
Yeah, we can see.
Oh, you can? Okay. So I don't have to change what I'm sharing.
So I'm able to see ChatGPT
Okay.
automatically, it looks like.
Oh, good, thanks. Now, are you able to see the PowerPoint?
Yes.
Oh, okay. We have to change the sharing then.
What's the risk of doing social that?
All right, let's look at some problems now. Here we have 5 problems, simple ones, and show you that you can simplify the computational process by just using the templates. Okay, so what is this first one? It's a small data set, time series data set. It involves radio frequency inventory tags, and they've tracked the last 7-month period given in this table here. So we're asked to plot the monthly data using Excel. I'll just show you a quick one and then we'll use the template. So can I copy this?
Yes.
You guys can see Excel on your screen?
Yeah.
Yes.
Okay, thank you. All right, so here's the problem. If you use Excel, you can easily develop a time series plot or scatter plot by highlighting the 2 columns and then select, 2D line. There you go. That's a simple, and then you see that there's sort of a slight upward trend. So you can superimpose a trend line. And let's click there, right click, and then add trend line. And you can add trend lines, a line, a curve. So it depends on what you see in the time series data. You can superimpose the model that fits. Okay. And you can, let's move this aside. You can ask Excel to develop the trend equation. You can go back there, right click on the graph, and then, can I do that here? Probably not doing this.
I was gonna say click the plus sign.
Add trend line, and then let me
Or yeah.
pull this away.
There you go.
And then here's the linear. You can use exponential, logarithmic, polynomial, power, again, depending on what you see and which model would fit best. And then you can say display equation on chart. And I don't know if you can see that, it's kind of small, but you can change the font size by highlighting the, I don't want to make that bigger. Okay, so that's the trend line. Interpretation of the trend line, it means that for every month, the number of RFID sold increases by 500 units on average every month. Okay, why did I say 500? Well, the units is 1,000, so 0.5 of 1,000 is 500 units. Okay, now that's the sort of the longer way. Well, we can do that in a quicker way by using the template. All right, so you can pick linear trend model, and then I just copied the data and then pasted it, and there you go. So you see the equation. So if you change the label, RFIDs, the label for the variable also changes. Okay, so the template gives you a number of measures, the accuracy measures, but this does not have the tracking signal. For the tracking signal, you have to use the stamp model here. Okay, for you to be able to have the tracking signal, you have to have the actual data in your forecast. That's kind of information that you need. So simple, right? All right, how about this one? Problem 2. A cosmetics manufacturer's marketing department has developed a linear trend equation that can be used to predict annual sales of its popular hand and foot cream. So what you see here is the equation, the trend equation that they have developed from historical data, okay? Where they're defining F sub T, time period, the annual sales in 1,000 bottles, and then time period 0 is 1990. Okay? Are the annual sales increasing or decreasing? By how much? To answer that question, just look at the equation here. Per month, the annual sales is increasing by, or are increasing by 15,000 bottles on average. Why do I stress on average? Variability, right? Meaning some months it will increase by more than 15,000, some months it will increase by less than 15, but on average, it'll increase by 15,000. Okay? But we answered by how much. Now, let's extend this problem to say that we are now, let's assume that this trend from 1990 is still true 30 years later. Yeah. So let's say that we are now in 20. Oops. So that's the equation. T is a time code, starts in 0, and T0 is the year 1990. And then it should be over here. So this is the year 1990 time code. So the time code in a time series analysis is a sequential number incremented by 1. Most software start with a time code 0. Some start with a time code of 1. So pay attention if you're using software.
Do they normally go by years?
Not necessarily, it could be a
Okay,
week,
it could be
two.
different weeks or months.
Right, correct. So 1990 would be, because this one is a yearly trend, okay? So let's extend this to 2027. Let's just say we're trying to forecast 2027. Okay? So the time period code associated with 1991 is 1. And then we can just extend this to 27. So here, we're going to say our forecast for the year. Forecast for the year, we translate this equation into, it says 80, so that's the y-intercept plus the time code for 1990 is 0. So that would be that t in the equation times the slope of 15. So, for 1990, your base year would have 80. 1991 will increase by 15. Okay? 1992 will increase by 15. So we can just copy this all the way here. So for 2027, if you were using that equation to forecast the number of hand and foot cream that will be sold, we're expecting to sell in 2027, that would be like 635,000 units. And that will be the basis for your planning for the year. Materials, machines, people. In fact, that is the number that you'll, the basis for your planning for the year. But let's extend this further. Let's say that your forecasting, your planning is broken down by quarters. One, you want to forecast for the year, but you also want to be able to forecast by quarter. So the question is, what will your forecast be for quarter 1 all the way to 4? Knowing that your forecast for 2027, the year, is 635. What do you think your forecast will be for each of the 4 quarters?
Is there seasonality?
I'm sorry?
Is there seasonality?
Good question. Yeah, that's a question you have to ask yourself. Is there seasonality? This is hand and foot cream. What do you think?
Probably more in the winter.
Probably more in winter, when the drier, right? Right. So
Then we would need to be seasonalized.
then you would have to, for you to be able to not deseasonalize, but a seasonalized forecast,
Add it.
you'd have to have an information pertaining to the seasonal index. you'll have to have that. Okay, which you will use to adjust your forecast. So the deseasonalized forecast for the first quarter is simply 635. I'm going to fix that. Page 45, I'll fix it. Divided by 4, and then I'll just copy that down. Okay. So if you have the indices for each of the 4 quarters, you will use that. So let's put some contrived numbers here. Okay. Let's say the index for the first quarter, this is the winter, for example, maybe 1.2, or you can convert that into percent. And then second quarter, maybe 110, and then third quarter, 80, 90, and then 80. Okay, this 1.1, 0.9, 0.8. So I can convert these into percentages. Okay, the index should average 100. So for the seasonalized forecast, we will multiply. I'm using the multiplicative approach. Multiply the deseasonalized forecast by the index. So for planning purposes, materials, machine allocation, manpower planning, financial planning, this will be your forecast for each of the 4 quarters. Not these. The adjusted forecast. Good with that? Okay. Let's see what else we have here. We are asked to obtain the daily relatives for the number of customers at a restaurant for the evening meal, given the following data. I'm not going to show the computation here by hand because it's kind of a lengthy process, but keep in mind that the basic component of computing an index is this concept of how much volume of activity that transpires in a particular period relative to the average. So, was that this one? Well, let me copy that. And let me just use this, paste the data. Because what I want to do is I want to put the number of meals served in one column. So I can copy this time series data, go back to the forecasting set of tools. One of the options there is you have computing a quarterly index or computing a monthly index and computing a daily index. So since the data that we have is by day, we will select that and simply paste the. It's okay to alter the. You can always download if you mess up. All right, and then I'll remove these. So here's your plot of the original data, and then the red is the 7-day moving average. Remember we talked about before the more number of periods you include in the moving average, the smoother your plot becomes. So you can still also even superimpose if you want to. These templates are not protected, so you can alter your graphs, you can change the labels, but we can superimpose the trend line if you wanted to. So do you see that? Like that's a trend line.
With this interactive document, as you make changes, does it autosave or does it?
No, you have to save. You have to, well, as in autosave, as in save the file.
Meaning that sometimes Word documents or certain things from Microsoft.
I think it depends on how you set up your Office suite. So no, I mean, sometimes I think you can control it. I don't remember what happened, but there's an autosave
You
feature,
can toggle.
which is devoid of the, it's separate from the template. Okay, so we're good here? And here are the indices. So if you were the restaurant manager and you're projecting like 800 meals served next week, and your planning is on a daily basis. Well, 800 divided by 7. Then you apply to that the indices. That gives you your projected sales with seasonal component. Make sense?
Which tab are you on?
Which tab? It's in the 7 over here, computing daily index.
Daily. Thank you.
Okay. What else? Questions on this? You guys will like it because in my undergrad, we do the computation. Because the purpose of at least in the undergrad, is to show them part of it is developing how to develop models. Whereas for us, it's more application. Okay. Oh, let's experiment again. What am I going to use this time? ChatGPT. Develop 7-day index for this. I can see what's above, but let's see if it gives us similar numbers. Maybe it might be different, but not be exact.
Which version are you using? Which version?
Oh, ChatGPT.
Yeah, the free or paid?
No. This is a paid version. So how are these numbers close to what we observed earlier? 90. So there's some slight variation, and probably because in the way that the index is computed by ChatGPT. Maybe ChatGPT is using this red 7-day moving average, or maybe it's using this black line. Okay, so that's why you will see some differences. Or you can ask it, how did you compute the moving average? So, what formula did you use? Talking to it like it's a real person. Kind of scary, isn't it?
Make sure you say thank you.
Yeah, I do.
Actually, you should not be giving AI gratitude. It actually is worse for the system. So.
Really?
Nicer that you're
Right.
No, yeah, that is the case, but it's goal oriented, and then because it's.
Okay, so here's the explanation. If somebody asks you how did you come up with that number? It says it's average for the it's overall average. So there's the difference.
Yeah, when you say thank you, it wants to please you, so then it won't give you correct answers as often because it's just trying to get that thank you.
Oh, really? If I
Yeah.
say thank you, it'll give me the right answer? Is that what you're
No,
saying?
it won't give you. It'll start just trying to get you to say thank you, so it won't be as accurate.
But
Yeah.
yes, ma'am.
Is that your experience?
I feel like it almost is.
Alright, so here's let's move on to this next example. So in the restaurant example, we computed an index and used the index to seasonalize a forecast. In this example, we are asked a question. First plot the data. So I've already showed you how to plot the data. We'll skip that part. Oh no, let's do that because I think there's a lesson to be learned there. In fact, it's important that we plot the data so we can see. And then we'll insert.
The user would be frustrated.
We'll probably line with markers. So in terms of the first question. Yeah, does there seem to be a trend? The answer is yes. Okay, what is the trend? Superimpose the trend line. That seems to be increasing slowly. So there's a question for management or for a manager. This is about number of cars sold by a particular dealership in Illinois. Okay. Can we say, let's say that you're writing your report. Can you say that your sales performance was the best or better in December than in January?
It's relative.
What?
Relative.
What do you mean relative?
I'd say output. Quantity output.
Not the quantity also, but in terms of number of units sold. Look at these numbers here. What does it tell us about the behavior of car?
Oh, there's seasonal.
There's seasonalities. So you should not, right, the comparison of January.
This is car sales, so I'd assume these are like either off-roading vehicles.
I don't know, I mean, we don't know, but if you want to compare the performance during the year on a monthly basis, you will have to de-seasonalize the actual.
So wouldn't in this case you just divide the.
Correct.
Yeah.
So that divided by the index, so that will
And
be
it's 800 all around.
if units, cars, so. Then you can just make that as an integer. And so those are what we call as de-seasonalized actual number of cars sold. Meaning we removed the seasonal component. So now I can superimpose this data onto the graph. So we'll add select data. And then we will add, let's see, this group here, so the name, the seasonalized units, and then the values would be that look there. Okay, so from a management, if you were reporting and doing a look back, evaluating. What did I do?
Cover the data series.
Come on, it's done bad. Okay, there you go. I was missing the okay part. So if you were writing your report, how would you characterize performance of this dealership over the 12
Being
months?
saved by seasonality.
What?
I more or less sum it up as we're being saved by seasonality.
What do you mean saved by seasonality?
Well, in that drop during December.
Is that really saved, or is that if you're saying that your performance? If you were simply looking at the blue, you might say your sales performance was improving.
Right. That's what I'm
But
saying.
in reality, it's not.
That's what I mean.
Yeah.
It's like if not for seasonality, sales would genuinely be going down.
Well, if you remove the seasonal component,
Right.
you would say that your performance towards the second half of the year.
Or could you say that seasonality is hiding the trend of?
Yeah, if you're simply looking at the blue, but if you remove the seasonality component, your actual
Masking.
performance was worse than that.
Yeah, so
5 months.
seasonality is masking the
Yeah.
performance decline.
So in the same manner, if you use the CPI to remove inflationary.
Variables.
Okay, your best performance was in the month of March. So
They
you
had-
look back and say, what happened in March? What did you do a special marketing, advertising, or was the economy better? So you have to find an explanation why that happened. Oops. And you have to also find an explanation why this occurred. Make sense? No other questions there. So this one is the finding a tracking signal. So for this, you can use the tracking signal template over here. And just paste the data there, remove that. Okay, what's the tracking signal there? TS. It's 5. What does that mean?
It's
Higher than
it's outside.
plus 5, so does that mean that you're consistently under forecasting or over forecasting?
Over.
Under forecasting there. Your forecast is below the actual. Okay, so that's when you have a plus for tracking signal. If you have negative tracking signal, then it's the other way. Questions? Or do I have to refill my cup with vodka again? So for the weekly,
Use the templates, right?
yeah, there's a template. Or you can do some computations, or you can learn At least if you're not an Excel
You're
user.
a statistics guy, you know.
Okay. Questions? You know, in this book here, there's a lot of equations. I wish we had ChatGPT when we were writing this book. Because writing an equation is very tedious. Have you guys use the equation editor in Word? It's very
It's
tedious.
really hard.
Very tedious, but hey, maybe on the second edition or whatever. Brian, this is probably something you don't have to use Python or Creator. So let me finish this thought. Say that you want to create an equation for,
Yeah, sometimes the coding gets a little bit messed up. So it's not,
or say, exponential smoothing.
it'll show it in the chat, but to be able to copy it.
We can
from
copy
there,
and paste it.
You need to prompt it though, because
No.
you can't guarantee.
No, you can copy and paste.
Go ahead.
I've done it, so. Oh, look, took me like less than 30 seconds to,
Nice.
if I were to create that equation. To do this manually.
Now,
Probably
the
take me
real
10 minutes.
kicker is giving ChatGPT complex data and having it break down the data into that equation and making
Really?
sure that it's
Well,
correct.
Yeah, you can,
There's a
you
trick to
know,
that I learned.
again, it depends on the prompt that you give it. Garbage in, garbage out.
Combination,
But
and giving it the source.
Yeah.
Yes.
so it took us, I don't know how many hundreds of hours to write this book. We can probably rewrite this in maybe a day or two or something.
And then bump up your price.
What price? No, lower the price because the labor cost dropped, right? That's same thing in your PSG game. Look at your variable cost. Because the
Strike. When
You know,
price on
your-
it, factor in the cost of the software, you're paying for something.
Measure your strikes.
So this was, I think Mary Katie asked earlier about if I were going to discuss the BSG game. But when you are pricing your product or service, one of the most important is understanding your variable cost. If you get to the cost volume analysis, you'll see how much important it is that you are able to determine your variable cost because that will dictate your pricing, your contribution margin. Determine the break-even point and profitability. Questions? Those attending in Zoom, do you have any questions?
No questions from me.
No, we're all good.
Somebody?
No, thank you.
Alright, so maybe next time on your second, at the end of your second,
Year.
trial period. I'll show you the report I see. I don't know what kind of report you see, but you tell me. Alright, and then we'll talk about. Change ratio. So we'll address those things. Alright.
Last week's, we can mess that.
And let's. I noticed and get.
Real quick. I noticed they had 2 days first. I don't know. I think we quiz. Yeah, the second quiz for this year.
It should be 15, I think 12.
The 20th. I just.
Okay, thank you, yeah.
So I like to prioritize that.